normal here. I think we'll be pushing on the scheduling. It's the second time we have on Friday afternoon.
Second time in a row.
I think
Yes.
so.
I will sort that out in the next, just remind me at the next, before the next meeting, because that shouldn't actually happen.
So send it in the next, request for a slot put in. We have been already like
Yeah.
pushed.
Yeah.
Show them the scars.
Yeah. You can cry a little. That's okay.
Yeah, fine.
Okay, jokes aside.
We're at the bottom of the hour. It's time to start. Everyone in the beer working group know where you are? I figure if you stayed this late in the week, you're here for a very good reason. So, yeah. I'm surprised there's as many as there are, honestly.
Beer on Friday afternoon. Of course, everybody's here.
You missed it. There were times when we brought beer.
Yeah.
Yeah. Good.
Good.
Very
beer.
good. There are more of them. Just want to throw that out there. All right. So how do I start this thing? Go to the next page. There it is. That's strange. I don't see that here. Why is that? Change deck. The slide number. Yeah, I don't see the difference here. That's fine. I see it. All right. Note well. Being noted, we're going to assume everyone has read this. I can say with your nods of affirmation that you've all digested this and checked it with your personal lawyers. Good. Now we're going to note really well. There's even more things to be noted and well thought about. Nods. Confirmation. Good. Meeting tips. This is basically the UI that, unfortunately, if you're presenting, you can't get this deck until you've done all these steps. So it's kind of hard using this as a tip because you can't get the tips unless you have the tips. Anyway, we're here. There you go. Best of luck to you. And our agenda. Anything missing other than the obvious? Anything want to change? All right.
Yeah, and please sign in. So next time we get an even smaller room.
Yes, absolutely. That's a good point. Just because you may not be on your laptop, connect with your phone. It's also the tool we use for managing the queue at the mic. If there's a lot of remote people, it's important you use that so we can manage it correctly. I mean, it's not like I can't see you there and wave at you, but as Tony pointed out, getting our head count correct is important so that we get the right room size. They justify that. They don't just listen to our wants and needs. They look at our history. 6. Full agenda. What was that one there? 5 was agenda. Oh, and music. Got it. There's our actual agenda. There it is. It's full. This is what we should be looking at. Everyone there? Everything remembered? Everything marked?
Right. So we squeezed in the hackathon presentation quickly somewhere in the middle because that wasn't requested, but obviously of high interest.
Media feed. What's it doing? Connection recovered. Permission denied. My box is going nuts, but this is still here. Was Sandy going to give the update on this, or we give the update on that?
As you want. It doesn't matter.
So we do have a stack of drafts in the ISGQ. I'm not one to hammer them about that. Last I saw, they were flooded anyway, so I wasn't going to go after it. I figure if it's there, it's their job. If there's some pressing reason for us to get something through because of other references holding up to the doc, we can do that. But otherwise, they're professionals. They know what they're doing. They're overloaded, and they'll get to it. So I'm keeping them out of it until we need to. Marcus said, hello, world. Thanks, Marcus. All right. Now, this is the harder part. This happens continuously in every group, and it's, we're not unique. Finding shepherds. It's an important part of getting the doc through, but as you've already heard me said so many times, it's an important part of being part of the process. You got to get your head around that. So I always said, if you haven't written a doc before and want to get involved in some way, or you're more curious how the process works, it's great to be a shepherd. And the shepherd process is very simple. There's a list of questions that's in an RFCs you go from, answer that to confirm the document has gone through that vetting that we expect, and then you ship it off with the document in the ISGQ. Someone pointed out yesterday, it's also a great way to understand that document process, which is an important part of being a chair. So wanting to get a chair, spend your time in this one, writing shepherd's doc. So here we have 4 needs. We have 1 assigned and need 3 more volunteers. I'm not going to look for him in the room, although we had someone yesterday volunteer as a shepherd somewhere. Yeah, I thought it was great. I think it was maybe coming out of PIM. Just picked it up. So we'll take these as a list. We do the request after it's past last call for a shepherd. So that step has already gone out. Have you ever assigned one?
What?
You can't like force shepherding on someone. It's like that. We're here to, it's all a voluntary process. So to be part of the system, this is an important part of being part of the overall success of the working group, if not the IETF at large. So please volunteer.
Greg, if I may, Andrew Alston here, wearing my AD hat. I would say with regards to some of the docs sitting in the queue, if reviews come out that, indicate there are issues or nits, etc., docs get stuck if people don't address what comes out in those reviews. And I would really appeal to authors to keep an eye out when those reviews come back that do raise issues, and deal with the issues, because it'll actually leave your documents moving forward. Because otherwise, well, we end up in a situation where docs stuck in queues because the issues aren't being addressed. And there is one or two documents sitting there that have had open issues for a while where they're not getting addressed.
Docs from our working group?
Yes, no, yeah. For example, I was actually just checking this now. The BIER OSPF v3 extension docs need some updates, et cetera, et cetera. So if we can just, keep an eye on that when reviews come back, and it'll make the process a lot smoother.
And you can check that in the doc status?
Yes.
Okay, perfect. Thank you.
Right. There was an email 6 days ago on that.
Here we go.
Why more?
I think I have to request a second review.
BHBLS beer is looking for a revision as well, post-shepherd, post-review. Yeah. So we need a shepherd for OAM requirements.
Andrew, clarification. So when you said the LSR working group wants to have a look, is it up to us to request a review? Yeah.
Yes.
I will fire that off.
We've done review calls, and we've also done last calls on both lists before sometimes.
Yes, that also happened.
Okay.
And we have a new doc. We just got adopted. A new baby in the room. Okay. And thanks. All right, so we get back to the original agenda, and I know which document is supposed to go next, which is down there. OAM is up next. Greg. Excellent. All right.
Actually, you already done part before.
Did he?
Yeah, thank you. I appreciate it. Okay, let's.
I got to get the document first here. And it's. Why do I not see OAM? Oh, there it is. Boom. There you go. Take
Okay.
it away.
Okay, so just to give you an update of how we progressing the documents and what's the status. Okay, so we have requirements, ping, MTU discovery, BFD, and performance measurements using the hybrid measurement mode. Next. So all documents, number of offers are under control, which means 5 or less. We addressed on OAM requirements early operational and security comments. And yes, as chairs noted, we need a new shepherd. I can volunteer to trade shepherd role. So if somebody volunteers to take shepherd role for OAM, I owe you one, and I'll pay you back in kind.
Okay. So Mana signed up.
Thank you.
Notes. Yeah. Thanks.
Next slide. So put one on me.
What came out in the notes when I said that, it says it's a minor sign up.
No, it's it's equatable. So shepherd for shepherd. Okay, beer ping again under control, 5 or less. We address shepherd comments. I have not uploaded this version. I hope that We'll get back from Shepard whether comfortable with the proposed updates, and then upload it shortly. And then we'll be ready for the next. So if Shepard is satisfactory with the addressed comments, then we'll be ready for the next step. So probably IETF next last call and then ISG. Next slide, please. Okay, PathMT discovery had a good comments discussion with Human. Many thanks. I sent some proposed updates and responded to questions. So waiting to hear back. And I'm not sure we had their last call. So I might be lost in the process a little bit with this.
I can check.
Yes, because if yet not last called, then certainly that ready.
Yeah, absolutely.
Okay, so next slide. Beer BFD, again, so it's uses point-to-multipoint BFD and point-to-multipoint BFD with active tails. So the first variant of BFD is a standard-based, and it allows for leaves or tails to learn to monitor their condition of their multicast distribution tree. The second variant with active tails, they have several options. We more specifically addressed unwarranted notifications. So where the tails react to detection of the defect and notify the root by using poll sequence messages in BFD. So that something that we discussed earlier in the group, and there was this interest to cover that. This document is ready for the working group last call. I'm not sure if we have a Shepherd. So if it needs a Shepherd, I can offer second Shepherd on me. Okay, next slide. So the hybrid performance measurement. Some time ago, we had a discussion with Alvaro when he was AD, and he made some comment suggestions. Also, these comments were related to beer OEM requirement document. I believe that we reconcile and addressed all the comments and discussion that happened back then. So again, I don't know what will be the appropriate step, how to proceed, but the document is stable and we are ready.
If it passed last call, Mr. Shepherd, right, it's published time.
Yeah, okay.
All right.
Right. So look at the status. Things have been last called, and there was, a couple of comments in the Shepherd stuff, and you addressed that now. So abbreviated last call, I think.
Okay.
I'll issue in any case because that has been ages ago, and then all the comments.
Yeah, it's good to remind people that we have this work and solicit their speak now or forever keep.
So you have requirements, the MTU and the double marking, right?
Yes.
Yeah. Okay.
Yeah, but I think that we are doing good progress with the ping. Yeah, but okay, so I sign up for 2 Shepherd duties. Thank you.
So hello, everyone. My name is Michael Ment from the University of Tübingen, and I would like to share with you some experiences about P4 Tofino implementation of advanced stateless multicast source routing. Next slide, please. So a short overview. I will motivate why we go into that direction, and then I will first explain you the concept of advanced stateless multicast source routing. We are building explicit trees in the header, and we have basically 2 approaches. One is based on bitstring encoded explicit trees, and another one is based on segments. And here we talk about segment encoded explicit trees. And finally, there's also a combination thereof, which is most probably the sweet spot. The combination is most powerful, probably. So next, please. So motivation is that with BIER and BIER-TE, bit strings are typically 256 bits long, and that is not large enough to scale BIER-TE to large networks. So we have to partition BIER domains into sets with at most 256 nodes, use an set identifier to indicate bit strings for that set, and that helps to scale BIER to large domains. But large BIER domains require many sets, and when we have a set and a receiver in that set, we need to send one packet per set. And that leads to redundant packet copies if receivers are in different sets. This may be an issue for BIER, but it's much more an issue for BIER-TE. And if you want to have BIER-TE if you want to have tree engineering in multicast, then there is no good solution. We analyzed how many additional packets we need and how many redundant packets this generates, depending on the number of receivers and depending on the bitstring size. And here are some numbers, and we see that this essentially scales with the number of receivers. So those are the redundant packet transmission that we have compared with IP multicast. Next slide, please. Next. And here is the concept. So the idea is that we have a distribution tree. So that is the figure in the middle on top. So it's the numbers 1, 2, 3, 4, 5, 6, 7. That is the tree, and we can encode this. We can encode these tree structures into, say, a recursive unit. The red one, the blue one, and the green box, those are recursive units. Actually, also the gray one and so forth, but those are relatively trivial. So this is a multicast tree, and trees can be serialized so that we can denote them in a serial order, and this could be encoded into a header and sent out to the network. And the challenge is, how can we forward such a tree structure in packet headers? Is that feasible? Can this be done efficiently? One constraint is, well, maybe the number of receivers does not fit into the packet. Okay, then we need to send another packet to reach all the receivers, but this is something which is not caused by different sets. So this is only caused if you really have a large number of receivers, and this is not really the use case for that. This is when you have a sparse multicast tree and a large networks, then this is a good solution. So what is the forwarding principle when we have such a multicast tree in the header? This is depicted on the bottom of this slide. So on the left, we have the large multicast tree. We forward this to the green node, to the number 1. The green node extracts the recursive unit, which is in blue. So this is extracted from the header, and this is then essentially the next header. It can be sent to the blue node. The blue node looks into the header, finds 2 different trees, the gray one, which is a trivial tree, and the red one, which still really looks like a tree. And these 2 packet copies are forwarded to the destination, which is node 3 and node 4. And node 4, again, does the same thing, extracts the subtrees, which are the trivial trees 5, 6, and 7, and they are delivered to the destination. So this is the idea. In a packet, there are multiple subtrees. They are extracted from the subtrees, we make a packet copy and put the individual subtrees into the different copies of the packet. Next slide, please. So we have basically, we found two choices how to implement that. The one is a bit string encoded explicit tree, and the other one is a segment encoded explicit tree. So what's the difference? With bitstring encoded explicit trees, we indicate the next hops by a bitstring, like on the left side. And you have seen previous drafts about that. These are the drafts from Turles in the last 2 years. It's CGM2 and RBS. And the new draft about RTS, which has been proposed in the PIM group, that actually utilizes segments and segment IDs. So on the right side, you utilize these IDs, number 1 and number 2, to indicate the next hops, and you do not utilize bit strings anymore for that. So this is the difference between bitstring and segment encoded explicit trees. And this is essentially what we have built on Tofino. We have a prototype which we call more or less RBS Lite. So it's not the full RBS functionality, but it's the essential functionality. And we have also implemented a segment encoded explicit tree on the P4 Intel Tofino, which runs at 100 gigabits per second. This should not be a productive platform, but it should be a proof of concept, because whatever is implemented with P4 on Intel Tofino should also be simple enough for other platforms that are more flexible. Next slide, please. So now I go a little bit more into details for the RBS we have implemented. How does the header look like? When you look at the header on top at the right, you see there is a next protocol field that points to the payload. And then we have a length field, L0 and R0, which essentially says there will follow a recursive unit of length L0. So, and the recursive unit may be large, because this recursive unit contains multiple other recursive units. So those are the subtrees I have been talking about on the previous slide. And in this recursive unit, what is there? This is a delivery bit, and a bit string, and some padding, and then come length fields and another series of recursive units. Okay, next slide, please.
So we are already tight on time.
Okay, then let's go to the next slide. So what are the properties of this RBS? The advantage is when you have a big string, you can do efficient replication at the leaf nodes. But the disadvantage is that if you have a long line, you need to encode each and every intermediate node, and that requires lots of header space. So therefore, when you have a very long line, the RBS has some disadvantages. Next slide, please. Segment encoded explicit trees utilize node IDs that we call segment IDs. And you see that the header contains multiple segments. Again, this is a kind of subtrees, what you see here, but it works a little bit differently. Next slide, please. So what is in a segment? In a segment, there is a segment identifier, there is a broadcast bit, which is also in the other version, a deliver bit, and some padding. So this is the part of the, and this part needs to be byte aligned for efficient processing. And afterwards, there is a length field, which indicates the size of the next subtree to follow. And the next subtree may contain multiple segments. Next slide, please. And the forwarding here works as follows. We remove the first segment and then we repeat until the packet is empty. First, we take the next segment and the next L bytes, which has been indicated by the length field in the first segment. And we forward the new packet according to the SID in the first segment. And then we remove the segment and the next L bytes from the original packet. And this is done as long as the original packet has been processed. By this way, we basically create we extract the subtrees for the next hops and create packets for these next hops. Next slide, please. The advantage of this segment encoded approach is that we can efficiently encode multicast trees with long lines. So because we can jump over many intermediate hops, and the disadvantage is that this approach is less efficient for replication to many neighbors. Next slide, please. Okay. Why is a combination of segment encoded trees and bitstring encoded trees most efficient? For bitstring encoded trees, we can do an optimization. Namely, we can basically remove all the header. We can remove the headers, the trees from the. We can replicate at the penultimate hop very efficiently. We do not need to have a recursive unit for all the leaves in the tree structure, and therefore we can basically do a beer style replication at the penultimate hop towards the leaf nodes, and that is very efficient. So the idea is to combine both the segment and bitstring based approach so that we have segment encoded explicit trees in the middle of the network and bitstring encoded explicit trees near the leaves. And yeah, next slide, please. To visualize that, here's a special case. We basically carry a packet over segment encoded trees paradigm towards penultimate hops, here over 2 hops. And this requires 2 bytes segment identifier, 1 byte length field, and 1 bit string, and a bit string of 1 byte to reach each of these penultimate hops. And when you do the calculation, how many receivers can be addressed, then with a bit string of 256 bits or a header with 256 bits, we can reach 56 receivers. And if we go to a larger header, this is 1024 bits, we can reach 243 receivers. However, here you may say, okay, we go to larger headers, but doesn't this make problems? Well, from this large header, we need to parse only the first few bits because all the addressing is in there. We do not need to parse the very far bits because they are just copied and they are not really processed. And the efficiency can be larger if we utilize the broadcast bit, because then we can address many leaf nodes that are connected to the penultimate hop. Next slide, please. So here's the conclusion. So in our implementation, we looked at bitstring encoded explicit trees and segment encoded explicit trees, and they allow for generic multicast trees. We think that may scale better than BIER, especially BIER-TE in large domains with sparse multicast trees. We've implemented that on P4, on Intel Tofino, and the advantages of segment and bitstring encoded trees can be combined. That means we basically carry a bit string over segment encoded trees to address leaf nodes of the tree. However, this combination is not yet implemented. This is work to do. And a technical report will be probably finished by the end of the year, and I will then send a pointer to the working group. Thank you.
Thank you. Questions?
Questions? Otherwise, I have one observation. Nothing. Yeah, to make it snappy. So, looks complex, but as complex as it must be if you want to achieve your goal. We cannot send the tree into consecutive packets. We cannot split it up. Beer doesn't give you any guarantee of, keeping sequence. That's not what the technology promises. So think through that. Generic observation is that this is a solution that controls the replication points, right? This is not only a solution that tries to solve the problem of small number of receivers on a very large possible set, but it also controls the replication points. I encourage also people to think about the simpler problem, which is just prevent excessive replication without controlling, the replication point, which have a value, but you see the complexity involved.
Yeah.
You can control the replication point with any encapsulation. You
Can
can run
I-
an LSP over the top, you can do a segment running over the top, and then be part of the beer holder
So I
code.
encourage people to think a little bit wider. I mean, this
Yes.
becomes a pretty
Right,
narrow-stream solution.
We already have layered solutions for this.
Can I quick comment, even though I didn't do this queuing thing correctly here? Yeah, so
You shall be forgiven this
thank you.
once. Okay.
Yeah, so my original interest, of course, was coming from BRTE, right? Having worked through all that stuff, and DetNet as the strict hop-by-hop requirement to, really lock down the path. And when the colleagues said that they had done this scalability thing in China Mobile, comparing this, which I presented on Wednesday, I'm saying that is still all this simulation scale is a lot of work. And I think the only thing I wanted to put in here, which I had this haggle, was that we have this broadcast thing. So that also this humongous tree for IPTV, you go to a large service provider, you have 8,000 nodes. And I don't want to say, yeah, beer would be good in whatever form or fashion we have, but we can't get rid of the stateless one for the big IPTV case, right? And if I need to stitch down some tree, it doesn't matter what it is, because I can efficiently do the broadcast on the edge, then so be it, right? So, the whole point is still to get to complete deployments in large networks, even though majority of trees is small, some of them will be large.
All right.
Yeah, good
Anyone
reason.
else?
Thanks.
Thank you very much. This is good stuff, very interesting. Now we are before and just prefix redistribution.
So I'm taking notes for the moment. This is poor showing, gentlemen, and ladies included. Yeah.
It's too bad I was going to buy beer for whoever took notes. So
Yeah.
you're lucky.
Now I have to drink it all. Okay.
Okay, good afternoon. I'm Sandy Zhang from ZT. This is a short presentation for the update of beer prefix redistribution. The motivation of this draft is to merge several IGP domains into one beer domain and make the forwarding efficiency. So we used the proxy sub-TLB to improve the efficiency. Next. Thanks. Let's see, this is the update of the 05 version. This presentation, this draft has been presented in IETF119 meeting, and we received the comments from Siyu, and she suggested us to add a paragraph to make a clarification for the proxy range sub-TLB. So we add a paragraph to make the clarification, and the paragraph is there is maybe multiple border routers connecting two regions, and the same BFI ID may be advertised in the proxy range sub-TLBs from multiple border routers. So in such situations, the two more border routers will advertise the same BFI ID. They just say they can be achieved by them and not saying they have the BFI IDs. So that's all the updating, and we'd like to see if this draft can be moved on. And this draft has been in working group last call.
No comments. Who's read the draft? Who feels it's ready for last call?
It was over last year, so I don't
Yeah,
think.
also in. It's
If you want
in
to
last.
great response. We got response already then.
I pulled out the last call.
Yeah. There. So we need a shepherd.
Yeah, we
It's
need
always
a
next step.
shepherd.
Hey, yeah. Who is volunteering? There. We got a volunteer right there. Awesome.
That's one more. Yeah.
And we had Greg volunteering quite a bit too. We got some already. All right. Excellent. Thank you.
Thank you.
Source protection.
Hello everyone, I'm Yisung Liu from China Mobile. Today I
What's his name? Yeah, yeah.
One.
today I will introduce the beer source protection draft on behalf of my co-authors. Next slide, please. Firstly, I will give a very brief overview of this draft. This draft, the scenario is that the multicast source connects the two or more ingress routers. That means we have more than two BFIRs to avoid single node failure. And we have three modes and cold and warm and hot modes introduced in this draft and referenced to the MBOD ingress resident ingress router failover, and compared for the BFER selecting designed UMH and associated detection and switchover methods are analyzed mainly on the node failure and the work path failure, and also include the beer specific detection methods like the beer BFD, beer ping. Next slide, please. And this is the draft status and the next step. And this draft is has a relationship with the MBOD draft, and I think it's a specific protocol instance of that draft, and which have discussed the MBOD draft discussed the general multicast redundant ingress for router failure issue, and this draft gave a specific protocol instance, and this draft emphasizes on the beer environment, and the draft has adopted after the IETF 118, and now the draft has stabled, and the authors would like to ask for the working group last call. Thank you.
We have a question. Human?
Human with Golden Nokia. I'm just a little bit confused. I was reading the draft. I couldn't quite figure out what is like difference of this between this and UMH redundancy. So like, as you know, today, when it comes to the different tree types, we could have the picture that you were showing, and then you can use something like a UMH redundancy with looking at the unicast route or the bandwidth monitoring of each one of those PIMSs that is coming from the source to the receivers, and figure out which one of those BFIRs are the active ones or the standby. So like this is somewhat implemented at least by Nokia stuff. I just didn't understand what is the difference between this and UMH redundancy.
The three modes we have give the specific information about the MBOD draft. In beer draft, we focus on the method how to detection the failure with the specific beer environment. The three modes we have a very detailed information in that draft, the MBOD draft.
I realize that.
But MBOD draft is the general multicast. it's not focused on the specific protocol.
Right. So that's my confusion a little bit on the MBON. It actually says like there are multiple ways of doing this, right? You use BFD, you use bandwidth monitoring, you use unicast route where the source is being advertised from BFR1 or BFR2. Like all those stuff are already spelled out. I mean, maybe I need to read the draft again. I couldn't quite figure out what else is this trying to figure out, what other problems is this trying to solve. But anyway, I'll read the draft. Thanks.
Thank you.
We got another question?
3D ZTE, both of the drafts are all informational drafts, and they want to provide some guidance or information for the multicast deployment. So this draft is focused on the beer technology analysis, such as beer pin and beer BFD. And in the MBOND draft, it's a general analysis for it. So some general methods are including PIM or MLDP or something else is analyzed in that draft, and the beer specific information has not been analyzed in that draft. So that's the difference from of the two drafts. Yeah, both of them are informational. They don't want to solve anything. They just want to provide us information about the deployment. Yeah.
Mankamna, Cisco Systems. So I think we really have to think whether this whole use case itself is valid for beer or not. So doing source protection for MLDP or any technology where we are building tree versus beer, which is really not building any tree at state. Do we really need that kind of protection, or we should think about it, that how can we simplify instead of just taking those protection mechanism back to beer?
Jeffrey, go ahead.
Okay, so the MBOND draft was mentioned, and this draft is presented here. I think one thing I want to point out that may help explain Women's confusion. There is another RFC in BESS about MAPN ingress the protection, basically those three modes of standby. One may think that beer is just a provider tunnel that can be used for that RFC. I think that is something to be considered. I just want to clarify. I think Manka's point is more also be related to that. In fact, there is another draft in the BESS that also talk about ways of doing the ingress redundancy. So it's just a lot of things there. We should consider this all together.
Okay, thank you.
In BESS, the draft has been standard SRC, right? The best signaling for the MVPN. Yes. We refer that draft and we borrowed the three modes code warm hot from that draft and analyze the beer provider side. Yeah.
Bowman? Check your hand down. All right. No problem. All right. Anyone else? Anything else? So looks like there's a lot of discussion to take place before we even go to consider last call. We've talked about this, I think, before too, about the idea of using what tools are in the box, how to make things layered, not depend, having a protocol solution for everything seems to be busy. And some of that discussion needs to take place. I didn't follow it all here necessarily with Mike, so I apologize, Karina and all. But let's go back to the list, and I guess from the notes we can hash out.
Yeah, I'm keeping the notes. My generic observation ideally would have one solution, but people may have different deployment preferences. So don't restrict the discussion, into a cat fight. Who has the best? Yeah. Right? Go on the list and shake out what are the pluses, minuses. Is it worth documenting? Because if even some people deploy it that way, it's already worth documenting in my eyes. Should.
Okay, something quick. The RFC in the BESS we were talking about is indeed MVPN specific. So just want to point that.
Yeah, I mean, Tony, different options means lot of implementation. That's I mean, at the point that we are trying to interrupt even with a couple of vendors and having all these options, that's going to make everybody so confused.
Completely agreed. It's a laudable goal to finish out with the single implementation, but if you start a discussion with there will be only single implementation, it's not a good starting point. That was my only observation. Okay.
Sure. As I say, if it's not broken, why fix it?
Okay.
So next you doing this for him? Yeah. Oh, great. Okay. I was just asking who was doing that. I saw Jeffrey on there, but this is great. Thanks, Stig.
Yeah, hi, this is Stig. Ice couldn't be here, so I'm presenting for him. So next slide, please. So yeah, I should say this draft was presented some years back in BIER, and then it's kind of been lying dormant. But now we figured it's good to have it back. So there's a new revision now. So the main idea is if you want to have some kind of DR or DF, but we don't have PIM deployed, what do we do? So as an example, the IGMP MLD overlay we've been discussing before, you want to do BIER end to end and there's no PIM involved at all. So how do we determine who should be the forwarder? Like the first hop, who should be basically originating packets into BIER, and at the last hop, who actually wants to be asking to receive packets in BIER. So we would like to have something that doesn't rely on PIM. Also, the PIM DF election relies on the RP, which we don't necessarily have. There's also some cases where we might use different routing protocols. So today, PIM is pretty much the multicast routing protocol, but we have BIER and it could in theory be others. And it's good to have one single DRDF election that could be used regardless of which protocol. So next slide. So this is, by the way, so yeah, in the IGMP version 1, they kind of left it to the routing protocol to say who should be the DR. But people realized that was a bad idea when you had multiple protocols. So in IGMP version 2, there was like define how to do query election in IGMP itself. And yeah, it's kind of the same problem we have here. We want something regardless of which routing protocol we have. So next slide. So so the authors figured that IGMP was a good place to put the DRDF election. So just like, yeah, we need IGMP anyway at the edge for, you know, finding the receivers, and IGMP is independent of which routing protocol you have. And yeah, if you have multiple protocols, then you might select the DRDF first, regardless of the protocol, and that DRDF can use whatever overlay they have available. Next slide. So you have the IGMP query election defined in IGMP, and one easy way could be to say, oh, let's just let the IGMP query be the DR or DF. But it's very loosely defined. There can be corner cases where two routers are IGMP query at the same time. And that's not really a problem for IGMP queries, but it's a problem for DF election, as you might get duplication. So the attempt here is to define something that is more robust than the IGMP queries. And one thing is, yeah, DR and DF, you might use those as two separate terms depending on whether you're first up or last up router and so on. But here we'll just talk about DF election. We will basically use the DF for both DR and DF. Okay, next slide. And here's some more details about the election mechanism. So the main thing really I want to convey is like the use case for this, why this is needed, and I hope you might understand that. If you have any questions, I'm happy to respond to them. But yeah, I can go more into detail about the election mechanism. So, so one thing is that we do load balancing. So we do hashing based on group address that allows a different DF for different groups. Also, there's this list of candidates that is being announced. So it's like one router will basically listen to messages from all the other routers and then construct a list and announce that. And by having a single router that announces a list that everyone will use, we'll make sure it will be easier to ensure that everyone actually uses the same list, that you don't have any inconsistencies. Yeah, next slide. And yeah, one of the things that we do here is that there's some learn flag. Well, essentially the idea is that you can, and I'm trying to remember this now, but you can announce like, I learned just about the router and I'm announcing it, but I'm waiting for the router to respond saying that I got it before you accept that the router actually should be used. There's some retransmissions here as well. If a router doesn't respond, we will send another hello so the router can hopefully respond to that. Next slide. But yeah, there's some details here I don't like 100% remember. But yeah, basically construct this DAL, designated announcer list that are basically who actually should be the candidate DFs. And then each router will see if it is in the list, and if it is, each router will basically do this hashing based on the group address for each of the candidate DFs that are announced, and then you will use the highest hash value as the actual DF for that group. But yeah, as I mentioned, there's also some acknowledgement and retry mechanism to make it more robust. Okay, next slide. And I kind of said this, by having a single router responsible for advertising the list, it should be more likely that everyone has the exact same list and we won't have any duplication or loss. Okay, next slide. Yeah, there's no packet formats in this version of the draft. It was more important to get the idea across. I was saying how this is like protocol independent. So you could argue why should it be done in the BIER working group, but at least that's where we see a need for it now. And so it seems like a reasonable place to do it. But we should also, yeah, present this in the PIM working group probably.
Yeah, I mean, so we do see this having this multiple router connected to the host or to the leaves issue. Right now, like as you said, PIM is the way that we try to resolve the DR, so we don't have duplicated traffic. So I agree. I mean, if there's something better, we definitely need to look at it. But I would imagine that we want that for all PIMSs, right? I mean, for all trees, not PIMSs, sorry. Tree seed, whatever. We basically want to come up with a mechanism that addresses all the trees issues.
Yeah.
And I don't know how it's going to fit into your stuff.
And I can say one thing to consider maybe is if this is actually like a good mechanism and protocol independent, should we consider using it for PIM as well?
Yeah, I mean, absolutely. As I said, right now, exactly the way we do that is that we create like EVPN or a layer 2 domain, and we just send the PIN between the two routers to figure out which one is the DR, right?
Yeah.
I'm all for if there's something better. I would love to work with you.
Yeah, that's great. Okay, thanks.
Mankamna Cisco, I think this question is for ICE, and you are just standing in front on his behalf. So definitely this work is needed to have some mechanism to have DRDF election without being really dependent on PIM. But sending IGMP hello packet, I think maybe we will discuss more that how exactly it should look like.
David Lamparter, there's an existing RFC for multicast router discovery. This doesn't solve the problem, but that might also be something to stick this onto additionally. It's RFC 4286 from 2005. Maybe it's good, maybe it's not, I don't know.
Yeah, is that based on IGMP or?
Yes, it's also an IGMP packet type and an ICMPv6 packet type.
Okay, thanks. Yeah. I think that's it. Let's see. Yeah.
One more.
Niels Warnke, DT. I actually thought that this had gone through a long time ago. I think it started 2016, 2017 or something. I really support that this is being pushed through because I see a need to be solved here. The question for me is, what are the authors planning to do with it? Is that in a shape where we can say working group last call or something like that? Sorry, not last call, working group adoption, because it's still on individual track, right?
Right. Yeah. So yeah, I'm not an author, but I mean, I'm sure the authors are interested, and also for the IGMP MLD overlay draft we are doing here, we really need this solution.
Do a quick poll. How many people are interested in working on?
Who's read the doc?
Yeah. Okay. So that's such a
So we
small.
might get a vote. Who thinks it's ready for adoption? Okay, how about conceptually? I mean, adoption is one thing. That's not like last call. So resonate with anyone on need? There. I mean, the people who read it are in support. All right. So we can still take that to the list and get some response.
Okay.
Thank you.
My only technical observation quickly will be, I don't understand why the intermediate layer of these guys gathering, the collecting whatever the offers and trying to figure out who is the best helps any stability, but that will be technical detail once
Yeah.
once
So
there's
at
something
least,
more flashy.
yeah, at least the reason for it is to try to make it more reliable. But it could be interesting to do some analysis and see if it actually, makes much difference or not.
Okay.
Yeah. Okay. Thanks.
Thank you so much. Appreciate that, Steve. Okay, redistribution protection. Interop?
Yeah, the bananas.
All right, hero of the week.
So some quick report on the interop testing. Next slide, please. So we had an informal interop testing this week. We have Saba, who wrote the free router. He's remote. We have a basic control plane plus software-based forwarding for his implementation. His implementation can also support DPDK or P4 programmed hardware forwarding. But what we tested here is the software-based forwarding. And then Juniper, which I represented. We had virtualized the platform with our new ASIC. And then Nokia, Human, brought in the SR1 router here. ICE was there during the hackathon for emotional support. Next, please. Yeah, thank him. Yeah. So the left side is the physical topology. We basically have a Ubuntu a laptop running VMs, and it has two interfaces: one built-in Ethernet, one USB dongle Ethernet. On the Nokia side, they have 10 gig fiber. So we in between we put in a switch to bridge the gap. The right side is the logical topology. It's basically ring shape. In the laptop, we have three virtual routers there. Two routers are running as the MVPMP. In the middle is a free router as a core router. The SR1 router is also a core router connected by the host interfaces. Next slide, please. So we use the MPLS encapsulation. Bitstream length is 256. Number of sets is 4. ISS single level. We use the subdomain 0 and subdomain 10. MVPN is the overlay on the two PE routers. We use the aggregation labels, which means that all the VRFs for VPN use the same label that is from the default label space. This is actually different from the RFC 8556, which is MVPN for a beer for MVPN. In that RFC, the upstream assign labels are used, but here we use the aggregation label for better scale. It's also almost an RFC now. It's the RFC editor's queue. We use inclusive tunnel due to the topology limits. There's only one bit in the bit string. However, we do use static, we added static BFERs to the tunnel so that we can actually have more bits set in the actual packet. Next slide, please. There is another setup in Shaba's home. It's a Linux server running his free router with the Juniper's VBX as the core router. He used the PIM as the flow overlay. Next slide, please. We performed ISI signaling and MAP and PIM as overlay signaling testing. We did beer forwarding, very simple forwarding between the P's through that P router, whether it's a free router or NSR or VBX. All worked well. After some fixes, we did run into some issues. We fixed them. Next slide. We did have a lot of challenges. Some of you have noticed my stress during the hackathon days. Mainly those challenges actually come from the virtual testing environment. For example, in that laptop we have 8 VMs running, and it was slow to bring up the VMs and collections. And I'm actually very new to the virtualization and also to the free router. Really appreciate that Chaba gave me a lot of help, and we were on the call all the time. He was very patient with me to show me how to do things. So we ran into the bugs. Bugs fix was quick, easy, but it took a while to get them built and loaded. Once those kinks were ironed out, we made very good progress after the hackathon, whether it's virtual, the VMs, or with Nokia physical routers. Next slide, please. So some pictures. This is Chaba. He's carrying his Linux box in his home. Next slide, please. This is me and woman there. Look at his arm. He was carrying the router. We don't have a picture when that router was on top of a Uber taxi. It's huge. They couldn't fit it into the taxi with the shipping box, but they didn't take pictures. Too bad.
You mentioned you were stressed. Wait until you bring the real hardware through the custom. Then you're gonna be really stressed, especially US custom.
Yeah. Next slide. This is after we finished all those basic testing. We're thumbs up. I wish we could Photoshop the beer bottle into our hand.
So the banana is declared an official beer working group artifact, historical artifact, just like the beer bottles, unless you ate it already.
Okay. Next slide, please. So this one is actually very important. Indeed, in this interpreter, we did very simple, informal testing. It was not intended as a testing event for robustness of the implementation. We are considering a formal or more comprehensive interop testing as part of the EANTC in March. We want to welcome more vendors. I know that there are more vendors out there. They didn't come this time. I hope we can all be all together in that EANTC testing environment. The testing result would be presented in the MPLS World Congress. Nothing is set yet, but this is something that we are planning. The last important point is that we started beer 9 years ago, even though I still say beer is a new technology, but we started 9 years ago. And the reason it takes this long is because of what I call the chicken and egg problem. The operators have shown the interest in beer from the very beginning, but once they learn that most of their existing hardware cannot do it, they back off. Once the operators back off, the vendors kind of hold back. So we got into this chicken and egg dilemma. But now we actually have beer hardware capability from at least 3 mainstream vendors, maybe 5, and plus open source implementations. And that is across access, aggregation, edge, and core, end to end. from multiple vendors. We have the hardware capability. So now it is the time for the pioneering vendors and pioneering operators to work together to break this dilemma and really put this really good multicast technology into use.
Meta lesson is world domination takes time, no matter what you do, having ridden that bike. Yeah.
One packet at a time.
One packet at a time. Yeah.
Sandy?
Sandy 张 提议啊 if we have any plan for next beer hackathon in next year or some
I think we can do it the next IETF. Again, besides the IETF hackathon, the ENTC is a more formal interop testing place. We are seriously considering going there, but we're not limited by that. As you mentioned, another hackathon that we can certainly do that.
Thank you.
ENTC is also March.
Yep.
So, I mean, is it, how close is it?
Da-dam, Niels is announcing the check size.
I like your humor, but no, I'm really pleased to see the outcomes, and kudos to all of you who took part and made this possible. But you know, second to your thoughts, there's a saying in Germany: "How do you eat an elephant? One slice at a time." Yeah. So. So yes, I think it's great, and I would really
to not offend the elephants, that does not go into the notes.
That's okay for me. But yeah, so we, as you know, we are still considering BF for deployment, and so I'm really pleased to see that there's progress. However, I would also I need to say now, like to see the other mainstream vendors to chip in, and I think you have set the bars jointly, and it's now for the other vendors to take up the challenge and prove that they're capable too, I guess.
Don't call them to action. Roughly outline the check size, and the thing will follow.
Yeah.
Like I said, hey, distillation drafts, okay? Otherwise, we'll be done.
Yeah. So really sorry I couldn't be there. I was there on Saturday and nobody was there. And then on Sunday, somehow other things popped up. It was really stupid. So yeah, special prize of the jury to whoever kind of carried the most heavy box. On the other hand, I'd really love to see, so there is at least one free implementation, right? These free router stuff, right?
P4, yeah. Mm-hmm. Yeah.
The free router.
No. The free router with P4, yeah. Mm-hmm.
Yeah. But I mean, so one of the demonstration vehicles that really worked well in the past, you know, for people that don't want to carry hardware is really the one single big VM or so where you can set up a virtual network with all the stuff. I'm wondering if that free router stuff would allow you to do that, right? So a demo where you just run the application, it has a couple of virtual routers, and you just can play around it with a complete network in your on your notebook. Does the free router would give you that?
Yes, it's part of that. It's part of this testing as well. You
Right.
can run multiple free
Right.
routers in a laptop.
Yeah. So basically, it would be great just for any researcher or even, you know, in customers, right? You just have a single VM image, you download and play around with it, and when that passes you, then they'll come and ask for, let me carry a box.
Thank you very much, Jeffrey. That was great.
Oh, well.
Thanks to everyone involved by Interop. So just a note, the request and the idea for an interop went across the list, and then I think it might have even rat-holed into a handful of people, but you know, we bounced it back a few times, and still some people said they hadn't heard about it. Oh, that's going to happen. You know, the list doesn't mandatorily pop at you. You got to go read your email, and it gets buried in the IETF noise. I totally understand. So if we do this again, I guess we'll have to do like formal bold type announcements over and over again on the list, get people involved, or just make sure they, or at least give them the chance to say no. That's more important, really. So everyone's been informed, everyone can show up, and everyone has a chance. And hopefully that the seats at the table continue to grow. Thanks, everyone. All right, next bit of slides. TE/OSPF.
Should be quick, right? Time running out. Hi everyone, I'm talking about the two extensions, OSPF v2 and OSPF v3. Next page. First, I would thank AC, Les, Tony, Jeff, and Thomas for the comments and the suggestions. So basically, updates to the previous version, including merging two documents into one, and then some editorial changes. So basically, we merge OSPF v2 extension and OSPF v2 extension into one document. Next page. So that's the merged version look like. So this version contains both protocol extensions. Next page. So I would like more comments and also asking for last course for this one.
Jeffrey, yeah, go ahead.
So I see you merged those two, but what about, is that only for bit position or what about the bit ID advertisement? Is that
all included?
All
you,
included.
you suggest in the list?
Okay.
Just all comments in the last
Everything.
version.
Okay, great. Okay, thanks.
Dorlis? Your hand's up at the queue. Is that?
Maybe not removed.
I can cut your hand off right here. There, it's gone. Oh, Andrew.
Sorry, I forgot to use the queue. Bad me. Can we also just, because this deals with OSPF, also just get this one, just take a look at it in LSR as well, just to avoid any complexity.
You mean send it to LSR for review?
Yeah, I'll
Okay,
ask the chairs
I
just
can
to.
send it to Jill.
just
I
to
can
do
send
that.
it to Jill. Good suggestion. Okay.
On my action items list, yeah.
All right, questions? Move on.
Next one, yeah. So I'm continue talking about the BAT for broadcast link. Next page. So first, thank to Greg and Sandy for their comments. The updates to the previous version, including adding regions for duplicated packets and some editorial changes. Next page. Basically, there are two reasons for duplicate packet. So first reason is that a bit position is local to a node. That is that bit position is for link from myself to the other nodes. Because of this, every node X will only handle the bit positions in a packet that's for the link from that node. So for example, here, just look at the broadcast the tree here. So it's in green color. So node A, for example, at step 1, node A only handles the bit position 2' is in red color. So it just does, because this 2 is for the link from A to B, and then just send the package to B. So that's only can do, cannot handle see all the other bit positions. And then at step 2, node B only handles bit position 4 and 6, and then send the package to G and C. And at step 3, node G only handle bit positions 14 and 19, and then use for bit position 19, G will send package to node H. And then this is the first time node H receive a packet. And then at step 6, node C will handle bit positions 12 and 19. For bit position 19, node C will send a packet to node H again. So we can see that node H receive same packet twice. So next page. So this is one reason. Another reason is in the next page. So another reason is that we're missing information or not enough information for broadcast link. We know in IGP we have DR and the DIS for broadcast link. But that means we have pursuit node for each broadcast link. So here we just represent by PX. we can see that because in the bit position assignment, we only consider half of the link. And then the other half of the link, which connect pursuit node to the other nodes connect to the broadcast link, we just don't no information for that one because of this one. And then that's the, I think, one of the region for the duplicate packet. So next page. So as soon as we add this mission information and then just assign the bit position to the other direction of the link, which connects the pseudo node to all the every nodes on the broadcast link, and then this problem will be resolved. So next page. So this just give example, and then we have this new bit position assignment, and then if we go through each procedures on every nodes on this tree, and then we'll not have a duplicate packet. Next page. So I would like more comments and also ask for adoption calls for this one.
I think that's the question. No, Sandy's not going. Yeah, it is Sandy's going up. Okay.
All right, so we issue adoption call.
First, I'd like to make a clarification for Jeffrey's comments for the BRTE OSPF extension. The BIFT ID advertisement haven't been merged in your draft.
Which one?
BIFT ID for BRTE packets.
I think it is. I'll check.
No.
Check. Double check. I think all the comments
just
reject.
check it.
Yeah. If I'm missing, I edit it. I had no issue there.
Yeah.
I remember it's every comment I just read carefully and then address carefully.
Okay, that's for the previous draft.
Okay.
And for this draft, I'd like to see, because if we read the RFC for 1992-62 carefully, and we will find that there are many duplications for in the BRT deployment, such as if in order to reduce the BP resumption, so many edge routers will share one BP. So this your solution can't solve these situations, and your solution may make it worse in case the DNC flag is used. DNC, do not clear flag. So I think this draft can solve some information, can solve some situation, but not all the duplications situations in BRT. So I think if, in my opinion, if this draft has been implemented and deployed, maybe you can go for EXP. And if there is just a paperwork, please go informational. Yeah, that's my opinion.
It's okay. That's I think this one, I carefully read through that RFC regarding to broadcast link, the bit assignment. So I think in that RFC, bit assignment is only on one direction of the link for connect to the pseudo node. So that's missing information there. And then we need to add that missing information, but resolve the duplicate packet for broadcast link. But for the other duplication, and then maybe that's out of scope of this document. I know maybe we have more duplications somewhere out there. That's why maybe we need to work on that one.
So just so a corner case in BRT,
yeah,
right?
That's right. Yes,
Yeah.
yes, I know. Yeah, thank you for your suggestion or comments.
No, push it, release. There should be a good discussion. So I encourage extensive discussion, okay, where the stuff's worth doing if it only solves, partially the thing, and the stuff that you mentioned where the stuff deteriorates on the adoption call before we start to move and, push it on the LSR and they burn cycles. Thanks.
All right. Got it. Any other questions, comments, vegetables? All right. Thank you.
Thank you.
Taurus, nothing? Really? All right. We've got.
Yeah, you loop. So it's 1 minute behind. All right.
Luke.
Applause for the chairs for the incredibly tight time management.
Just pushing this button.
Good afternoon, everyone. This is Yuan Xiangqiu from H3C. Today, my presentation is about beer loop avoidance use segment routing. Currently, there is a loop problem in beer forwarding. As shown in the figure, the multicast packet sent from R1 to R9 is initially forward along the path from R1 to R2 to R3 to R4 and to the BFER R9. When the link between R2 and R3 fails, R2 will detect the route to R3 is unreachable and send the packet to the backup neighbor R6 according to the FR. If the convergence of R6 is slower than that of R2, during the routing convergence process, when R6 receives a multicast packet, R6 will send the message back to R2. This is a loop. If R6 convergence faster than R2 during the full recovery, is also a loop between R2 and R6. To resolve the problem, we propose a method using SR-MPS and the SRv6 to ensure that beer message can be forward loop furnace during the IGP convergence. Upon a topology change, BFR performs convergence process as follows. Step 1, after calculating a new path to BFER in an interval, BFR installs a BIFT for neighbor that can steer packet to BFER via a expressive path. Within the interval, multicast packet are forward along the expressive path. When the interval elapses, BFR install the normal post-convergence forwarding entry. In the figure, within the interval, R1 will forward the packet to R9 along the link between R7 and R8.
Question, Torles?
Yeah, so first of all, correct me if I'm wrong, but I don't think we ever get a real loop.
No, just once.
Yeah, it's not even looping because we're resetting the bits.
Correct.
Right,
So, it will
so
just drop the packet.
different to this queue here where, you know, I'm getting in the queue and I need to delete my bit myself. But so unicast has worse reaction on the micro loop problem than beer. And then the problem is when we're starting to build workarounds, that workarounds get into conflict with the CPU time that we actually wanted to spend to resolve the micro loop first.
Cold scar tissue to know that, right? Yes. No, but continue.
This is our method currently. We have two methods. Method 1 is BFIR use the concept of PQ space for TI-LFA to generate SR MPS and SRv6 based express path from P node to Q node. The second method is BFIR directly generate an express path from BFIR to Q node. For method 1, the repair list of SRMPLs is node seed of P and adjacency seed of P to Q. And for SRv6, the repair list is end seed of P and end X of P to Q. For method 2, the repair list of SRMPS is a genesis set of BFIR2Q, and the repair list of SRV6 is index of BFIR2Q. Next slide, please. This is it is an example. We still use the finger. The source is connected to R1. There are two BFER, R9 and R10. The multicast sent from R1 to R9 and R10 is initially forward along the path R1, R2, R3, R4, and R9 and R10. When the linker between R2 and R3 falls, or the link for recovery, R1 will calculate the repair path for each BFER. Step 1, calculate the PQ node for R9 and R10. The result is both BFERs have the same PQ node on R8 and R7 respectively. So the two BFERs, R9 and R10, will use the same repair path. During the IGP convergence process, R1 will forward the multicast packet to R8 first. After R8 receives the message, it will copy the packet to R9 and R10. This is our preliminary idea. Any questions and comments are welcome.
Jeffrey.
So regarding earlier comments, whether beer can loop, I think when we say beer does not loop because we clear the BSO as we forward, but here the situation is that for the same BFER, you forward to the next hop, and if the next hop somehow has the unicast looping problem, it may send back. I think that's the problem. So as long as the unicast does not have the loop or U-loop problem, we should be fine.
Even if unicast loops, you're extinguishing the bits. So when the stuff turns around toward the previous node, the bits are not set anymore. They will not, you will not try to loop. Without that, beer would have never happened.
But the clearing, if we're talking straight beer, the clearing is the end bits. So they don't get cleared until you've divided them out. So if it went from 2 to 6, it still has 9 in the list. 9 didn't get cleared, right? Unless it replicated something to 3 as well. However, 6's shortest path to 9 is not changed with this failure. I don't see how 6 would send it back to 2.
So to be honest, if on the spot to talk about that possible looping condition, I will have trouble to do that now. So, but my main point here is actually that even if the loop problem exists, then the unicast solution for the loop or micro loop, it can be applied to beer as well. Basically, beer just follows the unicast. As long as your unicast does not loop, you should have no problem. I think that's the more important point I want to convey.
And here's my observation. We actually don't have to extend beer to do that. I mean, if you're really that, concerned about this scenario, you can basically calculate the SR tunnels and fall back on ingress wrapper to go to everything directly with an SR tunnel. You don't need any special beer, magic.
That's my point as well.
Okay.
I mean, there is a little bit of a sad history, Stuart, Brian, and I did all this, ordered convergence stuff for the multicast, and then also we had ICE and others, this whole make before break based on that. But the unicast people kind of didn't want to have that unicast stuff, but rather LFA and other stuff. So yes, we know how to do things much better in unicast, but what they did for unicast themselves wasn't adopting these things that work best for unicast and multicast. So, I mean, I'm really not sure if this problem is really that relevant as far as overcoming big issues. So if people stand up and say, I have the use case, I need the performance, that's fine, but short of that.
So I just want to share, we got a minute, share just something anecdotal. When I was at a large corp 3 or 4 years ago and they've had enough of me, we had implementations and we did testing, and my primary interest in testing was convergence time. I mean, that's one of the many things that drove us to beer, but that's one of the biggest changes operationally, especially in MVPN. You got all this layered state, all that's gone. And it used to be all this management of your network state multicast to ensure that your replication, or excuse me, your convergence time would be acceptable. What you get now is deterministic convergence. That is, it does not matter how much flow state you have. It's just topology changes. And we're seeing like just a pointer shift to a fib change after unicast changes. And it's microseconds.
Yeah, I think one of the common things that you do have in routers for a long while has been the ability to prioritize a certain type of prefixes in convergence, so that those are converged first, or rather downloaded to the forwarding hardware first, which is where the problem lies. And typically when you do have an IPTV or other important multicast deployment, yeah, you can put those prefixes into that list and your convergence will be very fast.
So that just added, Beer allowed us to layer replication on top of unicast forwarding instead of integrating all that stuff together. So if you've tuned your unicast, well, Beer is just going to ride right on top of that. Like I said, it added some single digits of microseconds on top of convergence. So I would be fascinated. Those who have implementations, it'd be fun to see some of that data actually brought here if you could sometime.
Another point about whether we will have loop or not, I just realized one thing. For a particular copy to eventually reach a particular BFER, the bit for that BFER will never be reset along the path. So because of that, there could be loops if unicast has a loop. But once you address the unicast loop, we are all set with beer.
Yeah, correct. So if it's basically a single replication point that these guys can reach, it will be flipped off. But if it's a multiple BFERs at the end, yeah, the bits will stay on. So that's correct. So it was a fallacy thing.
Okay, Torres, I saw you had your hand up. Did I just chop it off, or did you actually? Okay, chop it off. Any more questions, comments? Anyone staying till flying out tomorrow? There we go. All right, I think there's going to be a beer crawl around here somewhere.
Thank you.
There we go. All right, you can get a happy handshake and a slap on the back. Thank you guys very much.
Thanks. Good session. We're on time. Good content. Thanks. Yeah, I know, Penny. Correct. Let me put in my action item.
Oh, yeah. Great to see you face to face.
Yeah. Yeah, I'm heading to the airport in 15 minutes. So I'm kind of